know what to focus this video on in terms of the camera, but anyways, I'm mostly going to talk about rocket ships, and that's about it. So, a little bit of talk about rocket ships and the future of mankind. So, the fact is that there are several different types of rocket propulsions that exist. And there are things that we have thought of but not created, like they've been invented but they haven't ever actually built them. And then there are things that we've built, and then there are things that we've built and used. Okay, and so in the 60s and 70s, we made what are called nuclear propulsion. And honestly, when it's talking about nuclear propulsion, it's talking about energy. It's talking about propelling atoms. Okay, it's not talking about propelling nuclear force, which is a gosh darn shame, because nuclear force causes a lot more energy to be released. And with more energy, there's potential for turning that energy into motion. The only thing is how do you do that? How do you turn energy into motion? And so when we talk about nuclear propulsion, there's really three different kinds of nuclear propulsion. One is using nuclear propulsion to propel objects. And these objects can be incredibly small, like the size of an atom. And a hydrogen atom is really small, so why not use those? And so that's what we've actually built and tested, but we've never flown something using those. And they build it so that we can take this hydrogen. I'm going to put the light up here. So we take hydrogen, all right, and we basically just propel it to close to light speed, okay? And we do that over and over again, using nuclear energy from a different hydrogen atom that has been split. Okay, and when hydrogen atoms are split, some people don't understand how small the explosion is, but it's smaller than the size of a grenade. And that might sound crazy to you, but it's not. In fact, we actually see some small-sized hydrogen explosions in some frictions out there that are actually pretty close to what would happen in real life. They're kind of eerie because they still have a mushroom cloud, and the force is still incredibly high. So the force is a lot more than the force of a grenade, but it's not super huge. It's not city-sized. It wouldn't devastate an entire city. If it happened on your block, it would devastate, maybe one block of a radius. Okay, you'd have about a mile of fallout, but that's about it, which is, considerably less. The thing is, it's very difficult to do that. Usually you don't split just one atom. It winds up splitting several other atoms around it that are close to the same heat that you had to heat up that first atom to. So, and the thing is, you just can't send. The other thing is, you're not sending one electron, you're sending multiple electrons. Okay? If you could just send one electron and just make one hydrogen atom split without hurting other hydrogen atoms, if that was possible, you could actually really use weapons like that, and they could be extremely small. I mean, hypothetically speaking, just in terms of advanced warfare in the future, you can have a nuclear bomb much smaller than the size of a grenade. After all, how small are atoms? How small are electrons? Well, they're extremely small. So it's only hypothetical, of course, because you need this massive amount of containment energy so that you can focus the electron. Otherwise, it won't ever split the atom. Even if it does, it's going to split multiple atoms and hurt you too. But hypothetically, distantly in the future, and we're not talking 100, we're talking like 1,000 years into the future, we're going to have the technology to take an atom bomb that's this big and throw it at an enemy and kill just them. Okay, and it's going to weigh almost nothing. All right, we're going to be able to throw it as far as we want. They will probably actually add weights to the bomb. Okay, it's going to be like a AA battery size. In any case, but what I really want to touch on is propulsion methods. So you can use this hydrogen method. That's one. Number two is using nuclear energy to harvest a high amount of electricity, and then use that high amount of electricity to propel something else that's really small, super fast, like an ion. Okay, and this gets into nuclear ion propulsion. So this is where you have nuclear reactors generating your energy you need, and then taking that energy and propelling a ion, which is much smaller than an atom. And there are other ideas, photon acceleration, which doesn't really work very well. Then you have things like, things like propelling hydrogen, but using like a railgun system. Okay, and a really good railgun that just charges up something extremely quick a really good railgun is going to send a little piece of iron near the speed of light. So if you can send multiple pieces of iron near the speed of light, they'd have to be very tiny. But if you could just send this stream of these particles, okay, and all of them are leaving your rocket ship at close to the speed of light, then you could have this acceleration of a very large ship that will just be constant acceleration, perhaps at 1G, perhaps at 2Gs. You wouldn't want to go much faster than that because you'd kill everyone on board after a few days, but human beings can sustain around 2Gs indefinitely. We're not exactly sure how long indefinitely means, probably about a month or so, but a month of 2G acceleration in space is a lot more than it sounds. Okay, that could get you up to over 150,000, 250,000 miles an hour, and maybe faster than that. And then when you approach your destination, you can then turn your ship around and decelerate at the same rate over about a month. Okay, there are some other space exploration problems that we really have to tackle first, alright, before we can explore space. The number one problem that people don't talk about is actually humans talking with each other. But let's get back to the nuclear propulsion. The third kind is the kind that people often think of, but they don't explain it well, and that's called plasma acceleration, and it's the acceleration from the nuclear energy itself. So if you take kind of a nuclear explosion, right, and that atom bomb just releases this energy and you put it all out. And it's not going very fast. It's not going light speed or anything. But it's enough energy from a small enough piece of material that it can propel you decently far for how much fuel you need. You're looking at 2 pounds of fuel for potentially half of a year of propulsion. And that's incredible. It's not as efficient as the other two methods I just mentioned, because focusing that energy at this point in time is almost impossible. It's much easier to focus that energy in the reverse, to focus it onto something else, to use lasers, and to propel that something else super fast. The only issue of that is a proximity issue. So if you're on the moon, which is this is exactly what we want to do. If you're on the moon and you're propelling a small object from a laser that's on the moon, that laser power is able to, basically you're banking on the fact that you don't have to have an engine on board. The only problem with that is that you can't have people on it because it won't be able to decelerate. Well, you could have a person on it, honestly. If you could probably have a volunteer, it'd be a suicide mission, but you could have a volunteer get on there if they want to, go past the stars and shit. But honestly, they're probably more useful. They stay on Earth. It'd be really fun, though, to be a volunteer on something like that, and to just keep floating through space until eventually you die. But So we need the lasers to be focused out from the ship. And it's kind of difficult to do that. Okay, you basically have to have that laser focused parallel. And to get that, we'll do it this way. To get that laser to focus parallel to the ship. Okay, so this is ship, this is your laser. Okay, to get it to focus parallel, you have to have accuracy that is way beyond what we have. If it's any way off, if it's just a little bit off, it won't be as efficient as the two methods I mentioned earlier, ion propulsion, and you'll wind up wasting more fuel for the ultimate speed that you'll reach. Although your acceleration might be a little faster, your fuel can only get you to so much speed, and your fuel will be exhausted before, versus carrying some extra atomic matter on you. And the atomic matter matters a lot, because we're going to land on moons and planets and other things where we can grab more atomic matter. It's not like using a specific elements like hydrogen, which is what we use right now. What we use right now is one of the three different kinds of conventional fuels: liquid, and solid, and what's called a reactive fuel. Okay, and so reactive fuel is something like hydrogen and oxygen, and although that's also sort of called liquid, it's reacting it into each other, so it's becoming water, and that's what your acceleration comes from. Versus normal liquid, which would be like gasoline explosion, which it doesn't really drive you all that much. It only works inside an atmosphere, blah, 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 blah. And then the next one after liquid is solid. And solid has extremely fast acceleration, but ultimately for the amount of mass that you have, your maximum speed, once again, your maximum speed isn't the best because it's difficult to focus that acceleration perfectly. Okay, if you could, and when you take the money and the time to make something that does drive, it's actually much better than liquid fuel, and it exceeds even the potential of reactive fuel like hydrogen and oxygen, but only by a very little margin. Okay, it's not. Some people I've heard talk about solid fuel like solid fuels. What's going to get humans on Mars? And then, no. That's not how solid fuel works. Okay, and your big problem is it's just heavy for what you get. And we don't really have engines at that level of efficiency yet. So even then, the best engines to use. We have booster rockets, for example. Booster rockets for the spatial takeoff. They used to be solid. They mostly just use they use liquid fuel now. They use oxygen, pure oxygen, and it just burns. Okay, they just light it on fire and it just burns. Now the hydrogen oxygen that burns and reacts, that reaction causes a further amount of energy to be released. And that's what we're really looking for. So when we're talking about, something that'll react versus solid fuel, that reactive fuel really does the best. So that's what we use now. The only other kinds of things that have been tried, we talked about railgun, but railgun using conventional methods is also possible as long as you can have enough containment that the piece of metal doesn't ever hit the sides of what you have, because if it hit the sides, it will break your cannon. If you have a strong enough railgun propulsion, you can get get really small objects to go ridiculously fast, and just have a stream of them, just have millions of them going. Okay, and it's not a bad idea. It's just we've never created that one. Okay, We've never created a railgun engine, all right, nothing that works. We've never made a nuclear engine that then is able to propel ions. Our ion engines are battery powered. So they're powered by little supercapacitors on satellites and a few other things. I think a couple of the deep space probes, used it. Now there are deep space satellites that use ion propulsion. A lot of people don't know this. They either don't talk about this or they just don't know that this exists. But there are actually deep space, so if this is Earth, this square here is Earth, most satellites are here, right? Yes. But then there's deep space, which is where gravity really starts to slow down and where you don't have to go very fast around Earth to keep orbiting Earth. And then you have further out. Okay, and way out here, about 3/4 of the way to the moon, there are a couple of satellites out there. Dude, what? No, hey, that's bullshit. No. There's a couple of satellites. They're like between Earth and the moon. I'm not sure how close to the moon they are, but they're at least like 1/4 of the way out there. I think they're like half the way out there. And they actually don't have to orbit Earth because they have an ion propulsion engine that's making them infinitely hover above Earth. It's not infinite like forever, but it captures ions from the sun and also energy from the sun, and it propels those ions at light speed or faster down towards Earth, or faster, well, whatever. It repels things close to light speed, the ions, towards Earth, using the electricity it gets from the sun. So that's awesome. Okay, that's ion propulsion for you. Okay, and it's not infinite, but it lasts for a very long time if you're using it at the rate of speed there's multiple satellites. All of them are Russian. That's part of the reason why in the United States you can't find information on them. Every single one of those are Russian satellites. Okay, and I think one of them actually has a nuclear I'm not sure if it has a nuclear reactor or not, but they definitely want to do something with nuclear reactive satellites that are deep space so that they don't have to orbit Earth. Now, some of those, they're going the same way as Earth's rotation, right? So, because they're going the same way as Earth's rotation, they're actually able to match the speed of Earth's rotation, and that's what makes those satellites so useful. They can be used for communication. They can stay perfectly centered over what they're looking at. And when you hear something like, oh, point your thing at the satellite that's over at so-and-so, it's like, well, satellites orbit. Well, no, they don't. Not all of them. And then you look for it. You can dig as deep as you fucking want. You can tell me I'm full of shit. You'll never find the information that you need to prove to me that these satellites aren't out there. But you won't find anything about what I'm talking about, because most of it's not in English. Okay, you have to use Russian pages and just translate it, but it's not common knowledge. It's not something on Wikipedia. It's not something you can find out there. But these ion propulsion satellites exist. Okay, they're very similar to the same engines, same technology that had the probes go out, except they're just on satellites. They're just sitting there. And unlike the probes, they're close enough to the sun they can actually capture some of the sun's ions, which is insane, of course, because it means that their propulsion isn't just long-term, it's infinite. Okay, they could just keep capturing it. They're hovering on the sun's energy, which brings me to light sails. Now, light sail propulsion is a great idea, but it only works close to a star. So one thing you can do is you can allow yourself to kind of fall close to the soul. If you've ever played one of those video games where there's a fan, and you can't jump up, but what you can do is you can jump down to the fan, and then let yourself expand or whatever, turn the fan on, and then that fan propels you ridiculous so that you can, go way up there. Okay, so that's what we're going to do right now. If we just go from the sun, where we are now, we go from the sun, we're going to go out there and we're going to accelerate like this. But if we allow ourselves to drop close to the sun, we're going to wham, okay? So that's some of the ideas for solar propulsion. Also, if it's going towards another star, then it won't work unless you perfectly aim yourself towards that star, and adjustments during your course can't really be made much longer after you pass your solar system, which is sucky, because if you're off, you're going to have some problems. And yeah, you could say, well, you can use conventional motors and stuff to avoid keep yourself on track, and that's just not really that true. So, yeah, so what's the next one that we got? I should have wrote this down first, but it's not how I do things. Pepsi. Let's see. That's about it. That's most of the propulsion techniques. There's not a lot of other ways. Oh, the thing about, there's this myth that you can use something like warp, but that only works after you've gone to the place. You can only open warp tunnels. Warp tunnels have been said to be plausible, but warp drives are going to use way more energy. See, the thing about acceleration is, if you accelerate yourself up to 9/10 or 99/100 the speed of light, you're going to go that speed until you decide to slow down. Whereas warp is quite the opposite. Warp is going to go much, much faster than light. But once you run out of energy, you're going to instantly stop in space, which has advantages. One of them is you'll be in hyperspace, which means nothing can go wrong. Wow. That's a comical statement. But the point is, you can't hit anything. All right, you're not going to hit a piece of dust. Although, who really knows? We don't know what hyperspace is like yet. Okay, it's very possible that we'll get into hyperspace and that there's already like a race of beings that are in hyperspace so much that they don't experience reality like we do, and that they got like a bunch of hyperspace dust floating around, and that's why I can never find my keys, because they get sucked into hyperspace and then flown back out somewhere else. Anyways, so who really knows what happens if we go into that? But we do know that there's a convenience to being able to shut off your engine and just stop right where you are. It's like engine braking in a car, except for in space. The moment your engine starts to slow down, you do. Once your motor stops, you stop. But of course, if you've exhausted your fuel and you don't stop in a place that has fuel, you're finished. You have no momentum. And so with those momentum problems, there's no correction action. If your engine stops working properly, there's nothing you can do about it. You're dead. So there's a lot of problems with warp, even if it can be invented. Okay? And the other general idea is that warp will use just as much energy as anything else will, meaning that, perhaps even more, meaning that if you use warp to travel from Earth to Mars, you will have used equal or more energy than would take anyways with conventional means, or with nuclear means, or whatever. Okay, use a nuclear engine. Maybe we got even antimatter, which we'll talk about antimatter some other time, because the problem with antimatter is banking. Antimatter works the same way that hydrogen fuel cells work, which I'm going to make a video on in a second here. But antimatter is banking on something you already have. You can't make antimatter while you're traveling with your engines and then use it. You have to make it first, fill your ship with fuel, antimatter fuel, and use it on your way. Once it's used up, it's gone, because making antimatter takes way more energy than what it releases, which is nuts, but it's true. Okay, the same thing with warp. Although warp is ridiculously fast and efficient, it's going to be a way that we're going to have to bank our energy up on that warp and then use the warp, and depletes your energy, and then you gotta wait until you generate enough energy to do it again. Just like a superhero that can teleport, but only ever so often or something like that, okay, which isn't always a drawback to their superpower, but in some cases it is. So that's that. The next point about warp is just that since it uses so much energy, and since you have to stop when it shuts off, long distance warp, which is where warp would normally be considered most useful, is basically a myth. Warping 20 light years won't work. It will be much more efficient matter-wise. We're going to use matter for all of this stuff. To power warp engines, you're going to need powerful nuclear reactors to generate the energy. But in any case, it might not be worth it to have warp in the sense that, let's say it takes 4 million pounds to go 20 light years using nuclear propulsion, using nuclear fission. Okay, fission and fusion combined, something like that. Let's say that takes 4 million pounds of matter. Okay? Well, then it's probably going to take more like 5 or 6 or 10 million pounds of matter to travel using warp to go 20 light years. The real question is, can we use warp engines to influence life in a way that changes how we use energy? That's the real question. Because if you can somehow use warp to, I don't know, assemble stuff really fast, if it has other uses, then maybe. But I don't believe in perpetual energy, and without perpetual energy, warp means that warp is going to take more energy, not less, than normal means of transportation. So, though warp holes, warp portals might be awesome, because if you already get a probe out there, and the probe can build some robots, and they can all build each other and use atomizers, which I'll talk about some other time, and they can build a tunnel, and then you got a warp gate, if you will, which, as Interstellar pointed out, maybe it would really be a spherical warp gate. It wouldn't be, it wouldn't be an actual gate. It would be like a gate with another gate and another gate, and you'd pop up there. You would actually, when you get there, you'd start really tiny, and then you'd expand to your normal full size, because that's how hyperspace works. Hyperspace gets you into a small, infinitesimally tiny area that's smaller than the inside of a black hole. Okay, singularity. And then you go from that singularity into existence. Right? Of course, whether or not the human body can survive warp, the answer is probably no. And even if the answer is yes, the body suit or whatever that you have to wear during hyperspace is going to be absolutely hysterical. But yeah, that's how warp will really be used when we start using it. And we're going to have to send out a bunch of scout ships. In fact, it's probably exactly what we'll do if we ever reach this level of technology. We'll have hundreds or perhaps even thousands of scout ships that are all capable of atomizing the Earth that they get to into metals, and then those metals can be transformed and used until they're create these warp gates, and these warp gates will allow you to warp gate into a place, and you'll go from one place to the next without any time. And see, that would be very useful. It will still use a bunch of energy, but only the energy from the stations that you're going to. Your spaceship won't need to use very much energy. The spaceship will have normal, like ion propulsion and other engines on board. And otherwise, the spaceship will be to visit all these warp canals, or whatever you want to call them, that will be positioned throughout our little universe. But that's just some information, a long-ass 30-minute video with some information on how propulsion systems will change mankind and what options we have for the future.